Peace be upon you and God's mercy and blessings. God willing, we will talk about the three-phase CT circuit to the protection relay, which is the circuit for connecting the current transformer to the protection stages, as we discussed in the last lecture. I will show you the lecture video now on the screen, and I hope those who haven't followed the lecture will do so. We talked about protection zones and understood how protection areas are determined and the concept of overlapping protection. Very nice. Now let's take a look together at the three-phase current transformer connection circuit to the protection relay. Our circuit consists of four main parts. Number 1, the three-phase current transformer. Number 2, the thermal block. Number 3, the test switch. And number 4, the protection relay. Alright, let's talk about the first thing, which is the three-phase current transformer, or the current transformer. One of the most important things to pay attention to is the stability or polarity of the current transformer. I have CT polarity, which comes in two types. Subtractive polarity, meaning that if the current direction in the primary is from P1 to P2, then the current direction in the secondary will be from S2 to S1. This is depicted in my drawing or schematic such that the dot point in the primary is next to the dot point in the secondary, as is clearly shown in front of you. The second type I have is additive polarity, which means that if the current direction in the primary is from P1 to P2, then the current direction in the secondary will be from S1 to S2. This is depicted in my drawing or schematic. A point in the primary corresponds to a point in the secondary on the opposite side, as is clearly shown in front of you. Now we have two very important rules. The first rule states that the CT polarity must be determined before connecting the CT to the relay in order to avoid relay force tripping for out-of-zone faults. This means we must know the current transformer's polarity, whether it is subtractive or additive, before connecting the current transformer to the protection stages. If connected incorrectly, it might cause the protection stages to send a breaker trip signal in the event of faults outside its protection zone. The second rule states that since the CT relay will be connected in a star connection, it is preferable as a method of organization and arrangement, and also to facilitate maintenance and fault tracking later on, to have a rule. This rule states that the star point, which is the neutral point, should face or be directed towards the equipment being protected, such as the feeder, transformer, or any other equipment. The second thing is the thermal block, also known as the rosetta. The thermal block is used for many reasons, including the ease of connecting wires to it, as opposed to connecting them directly to the equipment, where you might not be able to connect more than one wire at the same point. However, if we use the thermal block, we can use more than one thermal for the same purpose, considering that you have jumpers between them and you exit with just one wire. Another use is the ease of measurement from it during maintenance and fault tracking in circuits. And of course, you have more than one access point in the circuit, and you can modify the circuit very easily. Very nice. Among the most famous types of thermal blocks used for the purpose of shorting and isolating, which we will see in the next lecture, God willing, is the slide link TP like the OTA 6T. It has two positions, either closed or open. The third thing is the test switch, and as an example, there is the PFT test switch, or the finger type test switch. The test switch is used to quickly and easily test protection relays and measuring devices by injecting currents and measuring them using different injection devices. I can also inject through binary inputs and receive feedback from the relay as binary outputs. This type has two types of fingers. The first type is the normal finger, which is used for isolation only, like isolating binary inputs and binary outputs, isolating transformer terminals. The second type is the CT finger, which is used in pilot circuit attempts and has the feature of shorting and isolating. The last thing we have is the protection relay or protection stages. We talked about the protection relay in the lecture on protective system elements, and among its components are analog inputs, which refer to CT input and VT input. Usually the CT input in protection stages is 1A or 5A, depending on the order number you purchase the protection stages with, and of course this depends on the CT you will use, according to the application you are using. However, in some protection stages, there are two CT inputs, one being 1 ampere and the other being 5 amperes, like in the MICOM and GE. With this, we have become familiar with the components of the pilot circuit connection for protection stages. Hopefully, in the next lecture, we will see how we can connect the entire circuit and how we can use the shorting and isolating in a year.